Density is the mass per unit volume of a substance. It seems very easy to determine or calculate density if knowing the mass and volume of a substance. However, it is difficult to determine the density of many biomaterials and food products, since their volumes are very difficult to be measured due to irregular shape. For example, it is not easy to determine or calculate the volume of a corn kernel, or a soybean, or an apple. In this video, we will learn how to determine the volume, solid density, bulk density, and porosity of biomaterial, like soybean, using different methods. The first method is to determine soybean bulk density using a bulk density meter. Let's watch a video to learn how to perform the measurement using the meter.
Take your quart cup and place it on top of the 9000 AG and press the 0 button to zero out the weight of the quart cup. Then take your quart cup and place it into your 151 filling hopper and stand. Replace the hopper over the top of the cup. Then take your sample and fill the top hopper and fill the quart cup evenly by opening the door in the 151 filling hopper and stand. Once you have evenly filled the quart cup, remove the top hopper, take your strike-off stick, make 3 easy strokes across the top of the quart cup. Remove your quart cup and bring it back to the 9000 AG computer grain grading scale and hit your pounds per bushel button. This will give you your test weight for your commodity.
After getting the weight of sample, the volume of cup is known as 100 ml or 100 cubic centimeter in our lab. And then directly calculate the density using the equation, the weight divided by the volume. The second method is to determine volume and solid density of sample using water replacement method. When an object is completely immersed in water, the change in water volume equals to the volume of the object. Different devices can be used to determine the volume of different size objects. Let's watch a video to learn how to determine the volume and solid density of a soybean kernel using an analytical balance with density determination kits. After setting up the density determination system, we can start to determine the volume and solid density of a soybean kernel. Pick up a soybean. Put on the weighing pan, and then determine its weight in air. After that, completely put the soybean into water, and then determine its weight in water. Take out the soybean. Repeat the same procedure to determine the volume and solid density of at least 3 other soybean kernels. Based on this data, calculate solid density of the soybean using the equation 1, and then calculate the volume of the soybean using the equation 2. Finally, let's watch another video to learn how to determine volume, solid density, bulk density, and porosity of soybean using the third method, a gas displacement pinometry system.
There are two chambers inside the instrument, a sample or filling chamber and an expansion chamber. Note that for some AccuPick models, the sample is placed in the expansion chamber. We're going to pressurize the sample chamber with gas from a helium or nitrogen tank set to 22 pounds per square inch of pressure. To purge the system, open the fill valve and then the expansion valve. Then vent the gas out of the unit. Before analyzing, we purge the system using this process. The instrument contains routines to allow program purging of the sample chamber. We typically do this 10 times. You have the option to use anywhere from 0 to 999 purges. By filling the chamber and venting, it does a better job of cleaning the sample than just blowing gas over the sample. Then we'll start our analysis, which uses the same filling and venting cycle with time allowed for pressure equilibration. During the analysis, the instrument automatically records the pressure of first the filling chamber and then the filling and expansion chamber, P1 and P2. The unit then calculates the volume of gas displaced by the sample, collects this volume data, and together with the mass of the material, calculates skeletal density.
This is the gas pinometry system in our lab. Let's start the test by taking out the sample cup from the system. Before filling soybean into the sample cup, zero its weight, and then fully filling the cup with soybean sample. Weigh the sample, and then record the sample weight. Turn on the system. Connecting nitrogen gas cylinder. Put the sampling cup filled with soybean into the system. Tie up the cover. Turn on the valve to purge the system by nitrogen gas a few times. Start the test by filling nitrogen gas into the sampling cup, and then record the pressure P1. Turn on another valve to expand nitrogen gas into the reference shells. Record the expansion pressure P2. Open the release valve to release nitrogen gas from the system. After gas pressure going down, take the sampling cup out from the system to start another test. Repeat the same procedure to test soybean at least 3 replications. Based on this data, calculate the volume of the soybean sample. Calculate solid density of the soybean. Calculate the bulk density of the soybean. Calculate void volume of the soybean inside the cup. And then calculate porosity of the soybean. Eventually, write the lab report